Dear students, I am Mahesh Javalkar from Maratha Mandal Polytechnic, and today I am posting my fifth video on the a chapter of power supplies. And now today we are going to see what do you mean by IC voltage regulator. Okay, so here in this presentation, I am going to define what is IC voltage regulator, types of IC voltage regulator, fixed IC voltage regulator, and adjustable IC voltage regulator. Okay, so here let's start to define what is a voltage regulator, and then we will see what is the IC voltage regulator. Now we know that a voltage regulator is a device or a circuit which will maintain a constant DC voltage at the output even if there is variation in the input supply voltage or variation in the load current. Okay, even if the input supply varies or even if the load current varies, the output voltage has to remain constant. That was the concept of voltage regulator. Now if a voltage regulator is available in integrated circuit, that is IC form, then it is called as IC voltage regulator. Okay, so it is simple here. What do you mean by IC voltage regulator? Means it is a regulator circuit in the form of integrated circuit, that is IC, which is called as IC regulator. Then we'll go to see types of voltage regulator. Now in this IC voltage regulators, we get two types. One is called as fixed voltage regulator and another one is called as adjustable voltage regulator. In fixed voltage regulator, the output can be positive or negative, but it is a fixed value. Okay, so fixed output will be coming out of the fixed voltage regulator. Whereas in adjustable voltage regulator, the output can vary in a range given, and in that range you can choose what output you want, and at that particular output you will get a correct output voltage in the adjustable voltage regulator. So here first we'll go to see what do we mean by fixed voltage regulator. A fixed voltage regulator produces a fixed DC output voltage which can be either positive or negative. This is very important to know over here, which can be either positive or negative. So here these words positive or negative. Okay. Now if you see IC numbers which start with 78 series. Okay. 78X it is given. This XS can be any number as 05, 08, 12, 10, anything. Now 78 means it is going to produce positive fixed DC voltage. Okay, 78 means it is going to produce positive fixed DC voltage, and in that whatever XX value you put, that will come as the output voltage. If it is 7805, it will produce plus 5 volt. If it is 7812, it will produce plus 12 volt. Similarly, if you see the second series, that is 79 series, 79 series is one which will produce negative fixed DC voltage. So 79 means it is going to produce negative fixed DC voltage, and XX is one. What number you put here, that number will give you that particular output voltage. Okay, so if it is 7905, then it will produce minus 5 volt at the output. Okay, then we'll go to see exactly what is 78XX. Okay, and now we'll see what is 78XX. Now 78 series is a 3-pin positive voltage controller IC. It is a small integrated circuit used in a circuit to supply a constant positive voltage. The number 78, as I've told you earlier, the number 78 indicates that it is a positive voltage regulator, and XX indicates that the output voltage of the IC. Okay, XX can be replaced by the controlled output voltage provided by the regulator. For example, if it is 7805, then the output voltage of the IC is plus 5 volt. Similarly, if it is 7812, then the output voltage of the IC is plus 12 volt. Okay, if it is 7815, the output voltage will be plus 15 volt. If it is 7818, then the output voltage will be plus 18 volt. So in that way it will go on. Okay, so once you know that it is a 78 series, it is going to produce a positive voltage, And then after 7 8, what number you have, that will be the magnitude of the voltage, what will be coming out of that IC. Okay. So here if you see 7 8 series ICs and the output voltages, if you see the first IC number 7805. So here if you see the IC number 7805. So 7805 will produce 7805 will produce plus 5 volts. So here 7805 will produce plus 5 volt. Similarly 7812 will produce plus 12 volt. Similarly 7815 will produce plus 15 volt. 7818 will produce plus 18 volt. So the last two numbers define what output voltage will be, and the first, that is 78, will tell that it is a positive output voltage. Okay. So if you see practically what is 7 8 series IC. So for example, here we have shown 7805 IC. So it has three pins. The first pin is the input pin here. The first pin is input pin. The second pin is the ground pin, and the third pin is the output pin. So the input has to be given to the first pin with respect to ground, and the output should be taken from the third pin with respect to ground. Okay. So it has three pins in the order input, ground, and output. So an example of LM7805 is shown here. Okay. Then the connections, if you see 7 8 series IC. So here you can see that the input is connected to the input pin. So this will be your pin number 1. Okay. This will be your pin number 2, and this will be your pin number 3. Okay. So if you go back and see, okay, it was pin number 1 is input, pin number 2 is ground, and pin number 3 is output. So pin number 1 is input, pin number 2 is ground, and pin number 3 is output. Okay. So here you can see the input is given, the voltage input is given to this input line. So here the input is given. Okay. And here the output is taken. Okay. Now this input, once it is more than whatever the value of xx is, the output will remain fixed at the value of xx. Say for example, if this is 7805, okay, and if the input voltage is say around 7 volt. So here if you see the input voltage, if it is around 7 volt, so here 7 volt, then the output has to remain at 5 volt only. Okay, 5 volt only. So in that case, if it is 7 volt or 8 volt or 9 volt or 10 volt input, the output will remain at 5 volt only. Okay. So 7805 will give you 5 volt. 7812 will give you 12 volts. Okay. So output will remain at that particular number voltage output. That is XX, whatever is there, that a particular number output you are going to get. Okay. And here we are going to use Ci and C naught, two are capacitors with the input and output, so that oscillations and transitions are avoided. Okay. So here you can see in the above figure, it shows a fixed positive voltage regulator. The input capacitor Ci is used to prevent unwanted oscillations, and the output capacitor C naught acts as a line filter to improve transient response. Okay. Then similar lines you can also explain the 7 9 series. So 7 9 series also, it is a 3-pin negative voltage IC. It is a small integrated circuit used in a circuit supply to supply a constant negative input voltage. The number 79 indicates that it is a negative voltage regulator, and XX indicates that the what is the output voltage. Okay. So XX can be replaced by the controlled output voltage, and for example, if it is 7905, then the output voltage of the IC will be minus 5 volt. Similarly, if it is 7912, then the output voltage of the IC will be minus 12 volt. If it is 7918, the output voltage will be minus 18 volt. If it is 7920, the output will be minus 20 volt. Okay. So in that way it goes on. So same like 7 8 series, 7 9 series also, if you see here, if it is 7905, as I've told you, IC number, it will produce minus 5 volt. If it is 7912, it will produce minus 12 volt. If it is 7915, it will produce minus 15 volt. If it is 7918, it will produce minus 18 volt. So 7 9 means it is going to produce fixed negative value, and the next two numbers will give you what will be the output voltage. Okay. Similarly, if you see the configuration of 7 9 pins, the first pin is the ground. So here you can see the first pin is the ground, the second pin is the input, and the third pin is the output. Okay. So practically, if you see IC of 7905, so you can see that this will be a practical way of your IC construction. In this way, you are going to get a IC available in the market. So this is 7905. So here you can see the name is written as 7905 here. So it is a 79 means negative voltage supply, and 05 means it is going to produce you minus 5 volt. Okay. So it is a 3 pin IC. So similarly, our connections, if you see same like 7/8 series, you can have a V in here, you can give your input here, V in, you can produce the output here, V out. Similar, for example, if this IC is say 7905, and if the input is say minus 7 volt, the output will be minus 5 volt. It will remain constant at minus 5 volt. And even here C1 and C2 or capacitors are used to avoid oscillations and transient outputs. Okay. So if you see the fixed voltage are regulators, so we have studied 7/8 series and 7/9 series. Okay. Now we will go to see what is adjustable voltage regulator. Okay. Now adjustable voltage regulator produces a DC output voltage which can be adjusted to any other value of certain voltage range. Hence, adjustable voltage regulator is also called as variable voltage regulator. The DC output voltage value of an adjustable voltage regulator can be either positive or negative. For example, LM317 is a adjustable voltage regulator IC. Okay. Now here what we are saying is a IC which is acting as a regulator, but its output can be varied in a certain range with a certain range. Say for example, the range is 0 to 10 volt. So you can vary its output from 0 volt to 10 volt, and what output you want, you can fix to that output. Okay. So that is called as adjustable voltage regulator. So LM317 is an example of adjustable voltage regulator IC, integrated circuit. Okay. So LM317 practically looks like this, where the first pin, if you see, is called as an adjust pin. So here you can see it is called as an adjust pin. Second pin is the output voltage, and the third pin is the input voltage. Okay. So this is how your LM317 IC looks like. Then if you see the description of LM317, LM317 voltage regulator IC can be used for producing a desired positive fixed DC voltage value. Okay, desired positive fixed DC voltage value. This is very, very important. So it is going to produce desired positive fixed voltage value. So here, if you see, these words are important here. Desired positive fixed DC voltage value of the available voltage range So in a given range of voltage, whatever or whichever voltage you want as output, that you can design for, that you can fix for. Okay. So LM317 voltage regulator IC has 3 pins. The first pin is used for adjusting the output voltage. Second pin is used for collecting the output, and third pin is used for connecting the input. The adjustable pin terminal is provided with a variable resistor which lets the output to vary between a wide range. Okay. Now if you see the circuit over here, now you can see that the input is given here, the input is given here, and the output is taken out here. Now this output depends on what is the value of R1 resistance and R2 resistance. If you keep R1 as fixed, then if you go on varying R2, this resistance, then the output voltage will go on varying. So in a desired range, you can keep a particular voltage. So it is adjustable output voltage, but whatever you fix this R2 for, that output voltage you are going to get. Okay. And Ci and C naught again here are to avoid your oscillations and transients. And now here students, using the formula for the output voltage, where V out is equal to 1.25 volt into 1 plus R2 upon R1. So here you can see it is 1.25 volt 1 plus R2 upon R1. Okay. So here R1 and R2 are the resistances what was given in the circuit. If you see the circuit back, this is R1. Here you can see you are having R1, and here you can see you are having variable R2. Okay. Now what we will do is we will keep R1 as a fixed quantity. Okay. So R1 we will fix at as 240 volt. So let R1 be 240 volt. So here you can see R1 is 240 volt. Okay. Now, if I want a output voltage of 5 volt, if I want a output voltage of 5 volt, then our equation will be 5 volt is equal to 1.25 into 1 plus R2 we don't know upon R1. R1 is 240 ohms. Okay. Then in that case, R2 we will get the answer as 720 ohms. Here we will get 720 ohms. So R1 is 240 and R2 is 720. So here if you put R1, R1 as 240. So here if you put R1 is equal to 240 ohms and R2 is equal to 720 ohms, then output voltage what you will get here will be 5 volt. Okay, so that is what as an example we have shown here. So now if you want any output voltage in a particular range, okay, then you have to keep R1 as fixed and go on varying R2, so that that particular range you will get, and in that particular range which voltage you want, at that value you fix R2, then the output voltage will be fixed for your adjustable IC voltage regulator. Okay. Thank you, students. So here I have told you about IC voltage regulators 7.8 series, 7.9 series, and LM317. Thank you very much.